أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum. Today our topic will be acceleration of particle, that is motions, equation of motion for acceleration, uniform acceleration in a plane. You see the figure. Let us consider a particle in xy plane at time t1. Let it be at point E. Let the position vector be r1 and velocity v1. And at time t2, let the particle be at point B with position vector r2 and velocity v2. And we know that velocity is given by the tangent at that point. Now change in velocity will be equal to del v, that is v2 minus v1, v2 minus v1. So average velocity acceleration will be del v by del t. Direction of this acceleration is along the direction of the change in velocity. Now as delta t approaches t2, we can find the instant acceleration as limit of average velocity, that is limit of delta t approaches 0 acceleration of v. So limit is equal del v by del t, and that is dv by dt. So acceleration is rate of change of velocity at a point. Now in terms of components, v can be written as vxi cap plus vy j cap. So we can write v is equal to vxi cap plus vy j cap. Substituting the acceleration, we will get differences of vxi cap plus vy. That is difference of vxi cap plus difference of vy j cap, and we can denote the difference of vx as acceleration along x axis and acceleration dvy by as ay. So acceleration, we get acceleration in components ax iota cap plus ay j cap. The magnitude of this acceleration in curve components will be root of ax square plus ay square. Again, we know that ax is equal to dvx by dt and ay is equal to dy by dt. Since vx is dx by dt and vy is component of velocity along y is dy by dt, so we can write acceleration as second derivative of dx by dt2 and second derivative of y with respect to time. Now kinematic equations. Again, we see that average velocity acceleration is equal to v2 minus v1 by t2 minus theta, where v2 is the velocity at time t2 and v1 velocity at t1. Let us state let t1 is equal to 0 when v1 is equal to v0 and t2 is equal to t and v2 is equal to v. So we will get acceleration is equal to v minus v0 divided by t. So we get the first equation, kinematic v minus v0 is equal to 80, or we write it as v is equal to u plus 80. V is equal to u plus 80 in straight lines. In the motion along straight line, we write it v is, or here it is v is equal to v0 80, where v is the final velocity, v0 is the initial velocity, and a is the acceleration it is. We can write now it components. So this is the part where it differs from the motion along the straight line. We can write v as vx iota plus vy j cap. v0 is equal to vx naught iota plus vy naught j, and a is equal to ax iota plus ay j. Substituting these values in the equation, we will get v x iota plus vy j cap minus vx naught I cap plus vy naught j cap ax I cap plus ay j cap into t. You remember we just instead of single velocity we write in composition two component, that is one along x-axis, one in all the three quantities, that is v naught and a. Now combining the terms and equating the arranging the terms and then comparing the coefficient of iota I cap and j cap, we get Vx is equal to Vx naught plus Axt. So this equation V is equal to U plus At along x-axis, and Vy is Vy naught plus A, while Vy naught is the initial velocity along y-axis. These combine equation, these now, that is equation in plane is represented by two equations, one along x-axis, one along y-axis. They are similar, only the subscripts and the symbols differ. Another relation is position time. That position time, you remember, it is S is equal to ut plus 1/2 of at square in one dimension. Here again we take v naught and v be the velocity of person at time is equal to t is equal to, and then the average velocity is equal to, here we start from velocity in the velocity time relation, we start with acceleration. Now v is equal to r minus r naught t minus naught, that r minus r naught by t, that is r minus r naught is a v average. So r is r naught plus v average plus substitute the value of v average, average velocity, that is v naught plus v by 2, but v naught, v is equal to v naught plus 18 we have got from the first equation. Substitute, we get r is r naught v naught plus at by t into t. So it is over is equal to r naught, it is twice v naught plus at divided by 2 into t, that is r is r naught 1 by 2 twice v naught t plus 1 by 2 at square. So it's r is equal to r naught plus v naught t plus 1 by 2 at square, where we can see that this equivalent to S is equal to ut plus 1 of at, because r minus r naught is distance, r is position, final position, r naught is initial position, so difference between these displacement. So r minus r naught displacement, that is S, is equal to v naught is initial velocity ut plus 1 of at square. So this is a similar equation where the symbols we use are those position vectors which represent in the two-dimensional. Now we can write in the components. R can be written as x iota I cap plus y j cap. R naught can be x naught I cap plus y naught j cap. A can be written ax in components, ax I cap plus ay j cap, and v naught can be written vx naught I cap plus vy naught j cap. Substitute and simplify and arrange the terms. That is r, you suppose x I cap plus y j cap, r naught x naught I cap plus y naught j cap. V naught is vx naught I cap plus vy naught j cap into t, and x a t square, that is 1 by 2 a x iota plus ay j into t square. Now we can compare, we will get two equations, one with the x naught vx naught t plus 1 by 2 ax t square, that is x minus x naught is displacement along x-axis, so that is x is equal to ut plus 1 half at square, and similarly y is y naught is y naught t into 1 by 2 8. So if at in time t is equal to 0, r naught is 0, and so x naught is y naught, so we will get x is equal to here Vx naught t equals 1 half of at square, and y is y t equals 1 by 2 ayt square. So this way we have derived the equations of motion or kinematic equations for a plane. So remember, they are similar to the equation for, but in cylinder we use the symbol R for displacement, and we take the position vector variance, and we consider the equation in plane as the combination of two equations, one along x-axis and y angle. We use the symbols, different symbols, but the equations remain the same.